Hello guys! In this video we are going to talk about beta function. It's very related with gamma function, so if you haven't seen the previous video of gamma function, please stop now and watch it first. In this video we are going to introduce beta function and the relation this function has with gamma function. That is the reason you need to know a little bit about gamma function. The requirements are not too much, integral calculus a little bit. I know integrals are difficult, but a little bit, and we need to know how to simplify expressions as usual. Okay, let's start. Beta function is defined as you can see in the screen. Beta depends on two parameters, p and q, and is the integral between 0 and 1 of x power p minus 1, 1 minus x power q minus 1. Okay, again, this is exactly the shape of a beta function. If you change anything, then be careful, okay? It's not going to work exactly like I'm explaining here to you. Okay, if you see an integral between 0 and 2, wait a moment, you need to at least try a change of variables in order to get something exactly like as you see on the screen. P should be positive, Q should be positive, and you can integrate this. By the way, this integral, p is positive, q is positive, but no one is telling you that p and q should be natural numbers. Could be fractions, could be rational numbers. So this makes this integral a little bit more complicated. I am being sarcastic. It's much more complicated if p and q are fractions or rational numbers. So the idea is to calculate this integral in a really fast way. And this is where beta function becomes. Look at this. Beta depends on p and q, as I told you. P is this number, q is this number. So once we apply this in a specific example, then you will see that you need to find which is the value of p and q. I think it's not difficult. Then beta function, it's connected with gamma function. How this connection works? Okay, do you see? You can see here. Beta of beta q, it's gamma of p, gamma of q, and gamma of p plus q. So that is the reason you need to know a little bit about gamma function in order to calculate this. So the idea is that this integral can be calculated as this quotient, and gamma is something probably you already know. Okay, so we need to see an example. You will see it's useful, and again, look at this. It's very complicated integral. Could be a very complicated integral, and then we are going to solve it in a really fast way. Come on, let's see. Let's start calculating some beta function values. Imagine that you have beta 3, 2. Okay, by definition you see on the top of the screen, this is gamma of 3, gamma of 2, gamma at 3 plus 2. Okay, so gamma of 3, as you remember, it's just 2 factorial. Gamma of 2, it's 1 factorial. It's always one number minus 1 factorial. The number minus 1 factorial, sorry. 3 plus 2 is 5. Gamma of 5 is 4 factorial. Beta at 5, 3. Then, if we use this definition, this is gamma at 5, gamma at 3, gamma at 5 plus 3. Gamma at 5, 4 factorial. Gamma at 3, 2 factorial. Gamma at 8, 7 factorial. Probably if you even didn't remember gamma function, you are okay, it's not so difficult. It's just factorial of the number we have minus 1. This becomes a little bit more complicated when the numbers are not natural numbers, when it's a fraction or divided by 2. Okay, but anyway, it's very easy. Okay, so let's remember this integral. Okay. I'm putting you the formula here again. So imagine that someone, probably being me in the exam, is asking you to calculate this integral. It's the integral between 0 and 1. Okay, this matches perfectly with the formula. Then I have x squared. Oh, that's perfect. This corresponds to this term. 1 minus x cubed. Okay, this corresponds to this another term. Perfect. Then this is a beta function. I can apply the definition of a beta function. The problem is that this number, this 2, is exactly p minus 1. Which is the value of p? You in your mind, you need to think, okay, p minus 1 equals 2. I'm just making these two values equal 2 and p minus 1. Which is the value of p? Probably you are asking yourself why I'm going too slow with so easy ideas. Okay, let me go faster. So p minus 1 equals to p is 3. So this is the number I put here. Again, this should be q minus 1, so I need to add 1 to this value. If 3 equals q minus 1, q is 4. So that is the reason I put 4 here. So for next steps, the number you see here, you need to add 1, always. The number you see here, you need to add it 1 again. So this is gamma of 3, gamma of 4, and divided by gamma at 3 plus 4. Gamma at 3, 2 factorial. Gamma at 4, 3 factorial. Gamma at, be careful, 7, 6 factorial. And then this is just a calculation you can solve in any calculator, okay? So, probably you are thinking, okay, can be useful. I prefer just to solve this integral. Yes, of course you can say that, because this integral is a polynomial. Integrating this, it's easy. Even though it's going to take your time, because 1 minus x cubed, you need to expand this in order to obtain the polynomial, for integrate. Okay, guys. This is what we have seen. Oh, by the way, let me go back 1 second and tell you something. In this case, I just put an example, very easy. Numbers are natural numbers. Can I apply this beta function if this integral has rational exponents? The answer is yes. Imagine that you have here 1/2 and 3/2. So it would be beta 1/2 plus 1 is 3 divided by 2, and if this is 3/2, it's going to be 5 divided by 2. So be careful with this, because we need to practice. This formula is very important, but it can also apply when these exponents are fractions. That means that we are working with irrational integrals, and irrational integrals are difficult to understand. So I promise you, this is a very good way to solve this type of integrals. One more thing, and we finish with this idea. Yeah, probably you are thinking, yes, but the shape of the integral should be exactly like this. And the answer is yes again. If I just change a little bit, for example, if I just put x here power 5, the one inside the parentheses, this formula doesn't work. Okay, so be careful with that. Anyway, this beta function has another generalization. If we take the definition and apply a change of variables, we are going to find another formula, okay, in terms of sine and cosine. And I think this is very helpful when you are integrating, for example, areas, volumes, and applications of the integral. We will see this application in another video. Okay, guys. We have been introducing beta function, and we just calculated one integral using the beta function. Also, very important, remember that beta function is related with gamma function with a formula that you should remember. Okay, thank you for your attention.